right, ladies and gentlemen, let's go ahead and get started. So for today's bell ringer, you were given an image. It says, what energy transformation and forces influence this battery-powered toy car? Explain your answer fully. So this week we are focusing on energy transformations, right? We've talked about kinetic to potential and potential to kinetic. So this week we're going to be building on that and adding into this transfer of energy from mechanical to thermal, or maybe chemical stored potential energy into thermal energy and mechanical energy. So these are all kind of examples of energy transformations, and we looked at these a little bit more closely yesterday in our Nearpod, and we're going to add on that today with some guided notes. So I'm going to see what kind of responses you guys have come up with. A few of you are still missing. I only have a few posts so far. Okay, so remember that if the car is just sitting there not doing anything, then it has potential energy, has the ability to move. But if you notice, there is a fan blade mounted on the back. So once you take the batteries, and it tells you in the question that it is a battery-powered car, you put it into the car and then turn it on. At that point, the chemical energy stored in the battery is going to be converted into electrical and then kinetic. Kinetic as the fan blades move, ultimately pushing the car. So these are the types of energy transformation that you should be able to describe by the end of the week. Remember, we will have a quiz this week, and I'll discuss that in just a moment. So the toy car, again, toy car has potential. So does the battery, has chemical stored potential energy. You put it into the car, you turn it on, the battery is transferred from chemical stored potential energy to electrical energy, then to mechanical energy, and ultimately kinetic energy as the car begins to move. So that's how you would describe the transformation. So let's look at the assignments list for this week. A lot of people are not coming into the WebEx, so at that point, I don't know what else to do. But for those of you that are present today, these are the things you are responsible for. These are the grades that will ultimately be going in the grade book. If I don't get them all put in this week, they will be put in the week after spring break. So the Nearpod from yesterday, the 29th, that is a graded assignment. So if you didn't do it, you better go back and do it. Second assignment, energy worksheet. It's a Google Docs. That is going to be assigned the end of class today. So I'll go over how to do that and when it's due. And then on Thursday, we will have a quiz in this class, minor grades. So these are the 3 minor grades you should expect to be going into the grade book this week. Please make sure you don't get behind. You don't want to go into the week of spring break failing because you have not done any work. So here's a list of what you need to do and the dates. So when you look at this, for example, the Nearpod, if you didn't get it done, go to yesterday's folder, 329, click on it. The link is right there. So there's no reason why students in this class can't get their work done. So for today, what are we going to be doing? Well, we're going to do some direct instruction. This is school. Even though you are at home, you guys should be following along and taking notes just like every other student. So in-class students today, we're putting these notes in their notebook. So I am going to go through this with you. So you will do some note taking in your notebook. There's a couple of videos embedded in the PowerPoint that we're going to watch. And at the end of class, you guys will do an independent activity that involves a very short reading section and some worksheet questions. So that's where we're going today. So go ahead and get your notebook ready wherever you've been taking notes, and we're going to get started on direct instructions. So when you click on the link here, this is what's going to pop up. It'll say students will record the notes in their science notebook. This is the title for those of you that say organized 330 energy transformations. Now I am going to share the PowerPoint with you, but I've also included the PDF. So if for some reason I go too fast or you get behind, you can refer back to the PDF. Okay, I know everybody writes at different speeds, but we can't hold the whole class up for too long, all right? So I'll give you guys a minute to get some notes jotted down in your notebook, but if you get behind, you can always go back and access the PDF. So go ahead and get your science notebook ready now, and we're going to get ready to go through our notes. Okay, so today's notes are going to be on energy transformations. So what I want you to start thinking about is, what exactly does the law of conservation of energy really mean? And actually, before we get started, I want to adjust my settings. All right. So remember that the law of conservation of energy, what does it mean? Well, the total amount of energy in the system remains constant. Energy cannot be created nor destroyed, but it can be transformed. So what I've tried to do here is underline key points. So again, if you guys are following along, I'll give you a minute or so to take these notes down. If for some reason you get behind, that's okay, because you have access to the document in Schoology. So you can always go back and fill your notes in. So let's think back to some of the examples we looked at yesterday. In the video yesterday that was embedded in the Nearpod, he discussed the concept of a car. So if you think of a car with gasoline in it as a system, right? A car sitting there with gas in it has potential energy. Once you crank the car up, that energy is then being converted. It is being transformed into mechanical energy as the parts of the car move, thermal energy, heat is always being released, sound energy, electrical energy. So even though the form of energy changes, it's still going to be equal to the amount that originally started in the system. Okay, so it is transformed, it can be changed and move from one object to another, but it is always conserved within a system. So let's go ahead and move on to the next slide now. So another way to look at this is using the term energy conversion. And this is basically means that energy changes from one form to another. A great example of this is a roller coaster. So we've talked a lot about roller coasters, and we'll look at a video in just a moment. But remember that on a roller coaster, you basically have a shift from kinetic to potential. There's always going to be some energy loss in the form of heat due to friction as well. But energy conversion is just a simple way or another way to look at or describe that energy can change from one form to another. All right, so let's go ahead and move on to the next slide. And I'm going to share a video with you guys. It's just a little 2-minute video about roller coasters and energy at amusement parks.
You may be surprised how much math and physics go into amusement park rides, and more specifically, roller coasters. Common roller coasters don't have an engine, so something has to keep it moving through its fun and intense track. The key to making a roller coaster move is energy. Well, the roller coaster uses a motor to get to the top of the hill. And in the process, it is storing energy for later use, which is called potential energy. Then, you finally get to the top of the hill and gravity pulls you down the track, which increases your acceleration and velocity. This turns the potential energy to kinetic energy. Kinetic is energy that is being used or energy that is caused by motion. The roller coaster goes faster with more kinetic energy being used, which is why the car gets faster towards the bottom of the hill. The change between kinetic energy and potential energy changes throughout the ride. Eventually, the energy turns to friction from wind, the rolling of the wheels, and the brakes on the track. So you can blame friction for stopping the speed and enjoyment of your next roller coaster ride.
So hopefully you found that interesting. Just kind of a little video going back over the relationship between kinetic and potential energy and how it relates to roller coasters and other rides at amusement parks or fairs. So let's bring it all together again with the law of conservation of energy. Remember, the total amount of energy before an energy transformation is the same as after. So I tried to underline the key points here. So if you can remember that the sum of all the energies in a system is constant, That's kind of the key takeaway in terms of the law of conservation of energy and how it relates to energy conversions or energy transformations. One key point to take away from this as well, and this is something important that I want you guys to remember, is that all energy transformations, regardless if you're going from radiant to chemical or chemical to radiant, thermal energy, anytime energy transfers from one object to another or from one form to another, there is always energy loss in the form of heat or thermal energy. This kind of brings us back to the example from yesterday, the video of the perpetual motion machine. And this is also why perpetual motion machines do not work. And as of now, they do not exist, because anything that has moving parts, machines, objects that have moving parts, they're going to be losing some of that energy in the form of heat. So there's always going to be a loss. So anytime energy goes from one form to another, a little bit is dissipated as heat. So it's not 100% efficient transfer. That's why when you charge your cell phone, for example, the portion of the charger that's plugged into the wall gets warm. Same thing with your laptop. So when energy is being transferred, heat is being generated, heat is being given off. You can feel that. You've probably observed it. So in the next couple of slides, I've provided you guys with some examples, and we're just going to discuss these since you do have the PDF and you can refer back to the examples if you need. One of the first examples of transformation. So let's think about a wind turbine. So depending on where you live in the United States, some of the energy that you use as a citizen may come from, well, a wind turbine. They're pretty common in the Midwest where there's a lot of wind. So what happens is that the movement of the wind in the form of kinetic energy causes the blades on the wind turbine to spin. That is then transferred into the form of mechanical energy. So the wind is the kinetic. As the blades spin, that is mechanical energy. And as they spin, it causes electrical energy to be generated in a turbine inside the wind turbine. And that generates electrical power that can then be used in houses and places like that. A second example would be photosynthesis. So remember that plants, the primary source of energy that fuels photosynthesis is energy from the sun. So radiant energy coming from the sun, plants absorb it, they use it to produce chemical energy in the form of glucose or carbohydrates. So radiant energy can be converted into chemical forms. And remember, chemical is potential energy because the energy is stored in the chemical bonds that make up different types of material. So these are two examples. Let's take a look at two more on the next slide. So what about singing into a microphone? So it requires energy to produce sound. You may not have thought about it that way, well, but it does. If you've ever been really sick, sometimes you feel so sick you can't even talk because you have low energy, right? So that's kind of a good example. So sound energy from your voice goes into the microphone. It then moves through the electrical cords and then is released again or transferred again into sound energy as it comes from the speaker. So in this example, you're actually going from sound to electrical and then back to sound. The fourth example is a car or automobile. We kind of looked at this yesterday in the Nearpod. So remember that chemical energy is stored, fuel, during combustion in the engine, thermal energy, heat is produced. So it's burned to convert heat energy. And then this transformation moves into mechanical energy, making the motor and things spin. So these are just four examples of how energy transformations can occur. Remember, as you go from one step to another, a little bit is always lost in the form of thermal energy or heat. So now that we've kind of gone through those examples, let's add a few more things to our lesson today. And I want to add two terms, renewable and non-renewable energy. And I know these are terms that you guys have heard, but what exactly do they mean? Remember that renewable energy are energy sources that are continually replenished. So these are things like water. So if a dam is built along the river, the flow of water can be regulated to move through channels and cause turbines to spin, producing electricity that way. There's also wind, then of course the sun in the form of solar energy, and even geothermal sources. So places where there's a lot of activity in the earth or a lot of heat energy released from the earth, people can use that or kind of harness that as a renewable energy source. And typically renewable energy sources are also more eco-friendly, not always, right? Depends on the mechanism of the machine or equipment that's being used. But in general, they're good because, well, they can be renewed. They can be replenished. We can reuse them again. Of course, that's very different than compared to what we call non-renewable. And this is the primary source of energy that humans on a global scale use. So non-renewable sources are those that cannot be replaced. Once they are gone, they are gone. So non-renewable sources come from fossil fuels. So this is oil, coal, natural gas, and even in some material used for nuclear energy like uranium. So remember, they are called fossil fuels because they were made by the remnants of once living organisms, primarily plant material. But it took billions of years for the process to occur. So it doesn't necessarily mean that Earth could never undergo another process when organisms die and layers of sediment form and there's pressure and heat and all that. Yes, that could potentially happen again. But if you look at it in terms of a human lifespan, it is considered non-renewable. So it's not being replaced as quickly as we're using it. So the more crude oil, coal, and natural gas we pump out, eventually it's going to run out. Eventually there won't be any left. And that's why we consider these sources to be non-renewable. Once they're gone, they're gone. Okay. All right, so I'm going to pause there. The last video here was just a little video on roller coaster rides, but I'm going to go ahead and pause because I want to make sure you guys have time to get to the next assignment. So at this point, if you need to go back and fill your notes in, or if you prefer to print them, you have access to the PDF. So I'm going to show you that file. If you click on it, it'll pop up. And it's basically the presentation that I just went through, right? So everything is underlined. You see all the information here. The links are there if you want to follow them. So anything that you need for today's lesson, background information is embedded here in the PDF that I've provided for you. So does anybody have any questions so far? All right. Thank you, Jacqueline. So now I'm going to go back in, and this is the next thing that we're going to be doing today. Energy transformations, reading and worksheet activity. This is going to be your independent assignment for the day. In-class students had something similar to do as well once we went through our notes. So when you click on this, everything that you need is provided in the Google Doc. There is a due date here. It'll still be up there, but if you can't get this done and submit it in time, it's going to be late. So when you look at it, it says use the attached Google Doc, read the energy information, and complete the worksheet activity. This is a graded assignment. I've hopefully made that clear to everyone that this is going to count for some points. So when you open it up, you guys can type in this. It's not a very long activity. There's a very short introduction, just talks a little bit about energy, potential, and kinetic. It explains the analogy of a car. Once you finish that, you'll have 3 questions here. Then you'll move on to the very short article on putting wind to work. And again, answer the questions. There are 2 questions here. Then on the last portion, you guys, it says you can draw a line correctly matching the energy transformation. If it doesn't let you put a line in there, you can use a color-coded highlighter to do that. So if for some reason there isn't a way to draw a line, you can just kind of highlight something like that, or you can even write the description below it, as long as I know that you've actually done the assignment. Okay. After you've gone through this portion right here, same thing here, there's a little fill in the blank. So you're going to be describing the energy transformation in each of these scenarios. For example, the one about the glow stick. In the glow stick, chemical energy is transferred to radiant energy. So I've kind of given you that example right there. But remember, glow sticks are chemicals. You crack them, they mix, they produce light. So you would say in a glow stick, chemical energy is transferred to radiant energy. And then the very last one, you guys are just kind of describing the energy released in these different scenarios. And then on the very last question, you come up with your own examples. Okay. So this is your kind of independent assignment for the rest of today. You have more than enough time to get that completed. So again, that's attached as a Google Doc here. So I'm going to go back in and open up Tuesday's folder. So once you have your notes put in or in your notebook, you're ready to go. You guys can work on the assignment. So I'm going to stop sharing for just a moment. And I'm going to come back to my, here, it's a little dark, but you guys can see me. Hello, everyone. So again, you have your assignment. You know what you need to do. If you guys don't have any questions, you're good to go to break for the day. But please remember, I have put in a list of graded assignments and expectations for the week. All right. So if you guys don't have any questions, have a great day, and I will see you in class tomorrow. Please submit your assignment when you have finished. All right.